I'm Aaron. I am from Azavea. I'm like a walking advertisement today. I'm going to talk about the machine learning workflow at Azavea and how STAC has become the entire, the talking language among different components of our machine learning workflow. So basically, as I mentioned last time during the lightning talk, there are three basically connected applications: Raster Foundry, Annotate, and Raster Vision plus Vision. So basically, Raster Foundry is for geospatial data management, and Raster and Annotate is for generating the training labels. And Raster Vision, it has a lot of different uses, but one of the use cases along this workflow is getting the data from Raster Foundry and getting the training data from Annotate and run experiments and then visualize them in Vision app. So today I'm going to dive a little bit deeper on Annotate, which is a labeling tool made specifically for geospatial applications and geospatial data. So it is basically for generating training labels for different and popular machine learning problems, and it will talk in the STAC language in the very end. I will show you guys how. So before diving into this, we kind of grab these projects from Raster Foundry and turn them into smaller workable chunks into tasks so that they could be parallelized among different machine learning labeling teams to create these ground truth labels. And what you see here is an object detection UI. Basically, you are drawing labels around these geo objects based on the predefined classes. And the next one is the chip classification UI. So on this UI, all these task areas, they become the labels themselves. So basically, you are assigning different classes. Of course, you can assign, you can define more than one class in there. So it becomes a multi-classification problem in the very end. Another thing I want to mention is that you can add on top of these base map and the imagery to add a overlay layer. Basically, it has many uses, and one of the use cases that we can think of currently is to compare this overlay layer with the image you have and generate chip classification labels based on the comparison results. And the third UI, which is the Semantic Segmentation UI, it looks a little bit similar to the object detection UI, but the main difference is that it is basically drawing on top or underneath of the existing labels or the new labels, basically. And in the end, since this is a semantic segmentation problem, you'll be able to generate those unioned labels, and it'll be all the labels will be contiguous to each other, and there will be a rasterization process in the very end. Or if you don't want that, that's possible too. So talking about all of these stuffs in Annotate projects, how are they talking in STAC catalog? So yeah, all of the things happened since the last time when we were in San Francisco, when we were brainstorming about the ideas about having this STAC export idea in Annotate for exporting all of these scene items from Raster Foundry and label items from Annotate and package them together and generate a catalog of scenes and data that are portable and accessible. So this is basically the UI for creating it on the front end. A lot of things are happening under the hood, but basically you are assigning you are assigning licenses, and you are selecting the task statuses that you want the export to be in. And also the exports are going to be on S3. You can sync them to wherever you want, or you can download it as a zipped catalog. In both of these two options, all of the labels, all of the things in STAC are portable, which means that all of the links are relative so that you can adjust them to your uses. And since we have all these things in viewing catalogs, images, and corresponding labels, we can view them, of course, in QGIS and stuff. But we thought that it would be great if we can serve them with a dynamic STAC API. So we already have some data models supported in Raster Foundry and in GeoTravel Server. So we might as well, we're planning to working on this kind of the STAC API compliant server to serve these labels and serve these images in a Scala ecosystem. So now, Raster Foundry produces STAC items, Annotate produce label items and package the entire thing into different collections and package them together so you can sync. And Raster Vision will consume them and produce STAC, and Vision will be able to view these STAC, which are the experiment results. So there's one more thing. In addition to all the STAC investment that we've been done since the last time we were in San Francisco, we have already provided PyStack, which some of you guys have been in the session that Rob did, which was pretty good in my opinion. So PyStack is basically a Python library written in Python 3, and it can work with any stack, and it is supporting the latest version of the STAC spec. Also, Stack Packer. This is something that we're building internally, which is basically using the PyStack as a library, as a tool, and then get scenes from Raster Foundry, and then find labels from the OSM data and package them together in a stack catalog. So basically, it'll generate scenes and label data for you in a portable catalog. In terms of the stack roadmap that we're having, we already supported the Annotate exports for training data and for scenes. And starting this sprint, we are building a portable stack server that supports labeled datasets and scenes, of course. And we're building something called Stack4S, which is a type library that supports Scala tooling in the Scala ecosystem. And in the long term, we are enabling Raster Vision to write predictions as stack compliant feed, and also open source Stack Packer. There is one thing that is not on this slide. So the Annotate tool, we're planning to have it publicly available free early next year, and it's going to be supporting the Stack catalog export as well. If you're interested in more, we updated our website a little bit, so if you're happy to talk about it, I'm happy to talk about it. Yeah, and that's it, and sorry for running out of time.